This looks dodgy, doesn't it? Actually, it's a gift from our cousin. She's from France. They're quite old, but this is 100% old school high power paint relief from a while back when she needed a wisdom tooth operation. She wondered if we could do something interesting with them. So let's brush up on our extraction technique. Each tablet contains 500 mg of paracetamol and 30 mg of codeine phosphate. The challenge is set. How much of each pure component can we separate? Just a word of caution. Please don't eat the product. You'll have to use all sorts of solvents and chemicals along the way. It's not for consumption. Remember, kids, this is your awareness and emotional capacity whilst on opiates. Broken. Just like the tablets need to be for us to start the extraction process. Okay, so we first crushed up the tablets into a fine powder. Well, we've got our two target components in here, plus unknown pill binders and other substances. First thing we're going to do is use some water to dissolve out any water-soluble components in the mixture. Here's our setup. We've got a hot plate and stirrer, and the beaker sitting on top of this. We're also going to use a thermometer to measure the temperature of the mixture. Paracetamol is fairly temperature stable, but codeine is a delicate substance, so we want to be careful we don't heat it above about 70 degrees C for too long. Let's get a stir bar in here. We need to use enough water to dissolve out the water-soluble components, including the codeine phosphate, which is a water-soluble ionic salt, but not too much to dissolve the lot of the paracetamol. So we're going to start by using 15 ml of water. Salts will be fairly soluble, but the solubility of paracetamol in cold water is quite low. You can see here its solubility curve in water. Let's add the water to the beaker containing our crushed tablets. And now we'll get the mixture stirring. Now we're going to switch on the heating, just gently so that the mixture is warmed up a little bit. This will help to digest the tablets properly. Temperature is slowly rising. Nearly 40 degrees C. And now about 45 degrees. Okay, we'll keep it here at this nice warm temperature and continue stirring for the next 20 minutes. Okay, 20 minutes is complete and we've got the fine slurry of solid in here, which looks well digested now. Next we cover this up and chill it down to a low temperature. As we do this, a lot of the dissolved paracetamol should crystallize out, leaving other water-soluble components dissolved in the liquid. Okay, here we go. Just a few degrees above zero. You can see the liquid on the sides of the beaker has deposited some paracetamol crystals. While the mixture is ice cold, we set up to filter. Here's the fairly dry solid left behind in the filter. To make sure we've got everything out, we now repeat the process again. So we get the powder back into the beaker and set up once again on the hot plate stirrer. This time we're just going to use 10 ml of water. And we stir and warm the mixture again for another 15 minutes. Once again we chill the mixture right down to nearly zero and filter again. Now we've got two components that we'll work up separately. our filtrate from the two extractions containing any water-soluble components and a very small amount of paracetamol, and the solids from the filter which contain most of the paracetamol, plus any insoluble tablet binders and other additives. Let's deal with this first as it's the simpler of the two to manage. In order to extract our useful paracetamol, we will do a solvent extraction. Paracetamol is pretty soluble in alcohols and acetone, so take your pick. First we place the powder into a beaker. And now our solvent. We're going to use 30 ml of ethanol. You could probably also use azeotropic ethanol if you wanted to. Let's add the solvent. And now we heat the mixture gently on the hot plate until it's nearly at the boiling point of the solvent. The paracetamol should dissolve, leaving behind the tablet binders and fillers. Nearly boiling, so at this point we'll remove from the heat and filter the hot mixture immediately. This time our product is dissolved in the solvent and should be coming through in the filtrate. Here's the insoluble fillers left behind in the filter center. And here's our paracetamol containing ethanol filtrate. To get the product we now have to evaporate off the ethanol. We'll do this on a warm hot plate. Towards the end we'll speed up the film and you can see the crystals growing. And here we go. Our first product, 4.8 grams of just very slightly off-white paracetamol crystals. We'll save these because there are some interesting reactions we can do with paracetamol as it's quite a reactive compound. Now for the second workup. Here's our filtrate containing the water-soluble components, including our codeine phosphate salt. So what we're going to do is called an acid-base extraction. We can convert the codeine phosphate into free codeine using an alkali. This will then be soluble in some organic solvents and we can extract it. Let's check out the pH of the filtrate. Just slightly on the acid side. This makes sense because phosphoric acid is a strong acid and codeine is a weak base. To convert the codeine into its free base form we will use the solution of sodium hydroxide. Here's about a gram of sodium hydroxide dissolved in about 10 ml of water. We're now going to add this carefully dropwise to the filtrate, checking the pH as we go. Let's check the pH. Closer to neutral now. But still a way to go. You may be asking why bother being so careful? Well, the answer is two reasons. Firstly, the codeine molecule is fragile and we don't want to put it in with an excess of strong alkali. The second is because when we come to perform a solvent extraction in a moment, an excess of alkali can cause a horrible emulsion to form. You can see a slight cloudiness in the mixture. So let's check again. Strongly alkaline now. So we're done. The cloudiness in the mixture is actually some of our codeine-free base coming out of solution. So now it's solvent extraction time. Make sure you read up on the solubilities of the particular amine you're trying to extract in different solvents. In this case, dichloromethane is a good choice because it will dissolve the codeine easily but not the small amount of paracetamol that may be present in here. We'll use 10 ml to start with. DCM is denser than water so it forms a bottom layer as you can see. We could put this mixture into a separating funnel and shake it. but with all amines and chlorinated solvents in alkali conditions, there is a very high risk of an emulsion. So we'll do this differently. Stir vigorously for about 5 minutes, really mixing the layers up well. Then allow to separate completely. Now we'll use the pipette to extract the DCM bottom layer and separate it. Avoid getting any water droplets into the separated DCM solution. Okay, here we go. To make sure we've got everything, we'll repeat the process with another 6 or 7 ml of DCM. Here's our DCM solution of our product. Now we need to dry it and dry it well. Here's a small amount of anhydrous magnesium sulfate powder. Once added, cover the beaker up and leave for 20 minutes to absorb the moisture. We could evaporate this down to get the oily residue of the free base, but we'll be a bit more sophisticated. After 20 minutes we decant the DCM solution into a clean dry beaker. And now we've set up a hydrogen chloride gas generator. This is a flask containing some dry sodium chloride salt, and with a gas tube attached which contains some calcium chloride to dry the hydrogen chloride, leading to a bubbler which can lead the gas into our DCM solution. Here's a little concentrated sulfuric acid. When we add this to the flask, hydrogen chloride will be produced from the reaction with the salt. Okay, let's go. As the gas bubbles through, you can immediately see the cloudiness appearing in the mixture. This is our codeine being converted into codeine hydrochloride, the salt which isn't very soluble in the dichloromethane. Here's the result after a minute of bubbling. The cloudy mixture now containing our product is the hydrochloride salt. In large quantities you could filter this off, but we've only got a small amount here. The salt is very water soluble, so any water at all, even trace moisture present, will dissolve the product. So complete dryness is essential. Now we're going to evaporate off the DCM and see what we're left with. We'll do this on a warm hot plate so as to speed up the process, and so that as the DCM evaporates and cools the mixture, atmospheric moisture doesn't get absorbed in. Towards the end the product crystallizes out as a bubbly sticky white solid. It soon dries to a hard solid. We pre-weighed the watch glass and our yield is 190 mg of fairly pure white codeine hydrochloride, which is a 75% yield on the starting codeine phosphate in the tablets. Not bad for such a small scale. There we go. No complex reactions today, but great practice at some essential basic lab skills. The product is a little bit controversial as it's a restricted substance in many places, but that makes it a little more interesting. But nevertheless the theory is transferable to many other common compounds such as amines that you will come across. Thanks for watching and stay tuned.